We did not see a series, right?
No.
Only changing dimensions. Okay. Okay. Starting. Okay, let me start off with normalizer, then I'll just sit down and see what I've completed for you and what are the things that are left over, okay? It's taking time to start, right?
Yeah.
So let me start off with normalizer.
Sure.
Yeah. So let's see the concept of normalization, okay? And how do you implement the normalization concept inside your Informatica? Okay. So a normalizer transformation, the basic functionality of this transformation is to convert from rows to columns.
Okay.
Okay, that is from the data that is there in your source tables, which are rows, that can be converted to columns in the target table.
Okay.
Okay. Now, how does that happen and everything? Let's see. And it's a connected and active transformation. So normalize your data by receiving a rows from multiple columns, okay, to multiple row for each instance of column data. That is nothing but you will have a row and column combination. So for example, let's understand the entire transformation with this example. Okay, here in this example you have store and the sales. 100, 300, 500, 700 are the sales of this particular store. Okay, and store 2 sales are this. Okay, this is quarterly wise sales.
Okay.
Right. Now when I normalize this data that I have, what happens is it will return a row for each store and sale combination. Okay, that is a store and a sale combination. Store 1 100, store 1 300, store 1 500, store 1 700. Okay, so whatever is there in the rows here, that will be put into columns. Okay, so that this looks like this. Your target will be in this way. See, here you will have store and the sale. Store, sale, store and sale. Again, if you have completed till store 1, you will be starting with the next record, that is store 2. Okay, so in this way you will get your data, that is from rows to columns. Right. Now along with this, whatever it is returning like store and sale combination, it will return an index value. Okay, now why is it returning an index value? Is it will help you to identify each quarter here. Okay, see here we have store 1 and its sales, store 2 and its sales.
Okay.
Right, what if I want to differentiate between these? Okay, I want to differentiate the records between the store one only.
Okay.
Okay, or among store one values. Then I can differentiate with this index values 1, 2, 3, 4.
Okay.
Right? Again for store 2 I get 1, 2, 3, 4. This is nothing but the number of occurrences.
Okay.
Right? So the number of occurrences is, how do you define the number of occurrences? Is the number of ways in which your particular record is appearing. Okay, your store 1 is occurring for 4 times. Right? Again your store 2 is occurring for 4 times. So the store values are occurring for 4 times each. It means the number of occurrences is 4. Right? So that is called as number of occurrences. Now these 1, 2, 3, 4, 1, 2, 3, 4, these indexes are called as GCID values. Okay. Here you can find. The default ports inside your normalizer transformation are GCID and GK value. Okay. So GCID, what happens is the normalizer transformation generates this ID column for each set of multiple occurring columns. Fine. So here what is happening is these are your GCID values. They are called as generated column ID.
Okay.
Okay. So these values will be generated by default using the default ports, that is your GCID.
Okay.
Okay. Now everything is fine. I have my store values, I have my sale combination, and I have an index value which is it is able to refer one particular record. Okay, but we have a repetition of the GCID values here. Okay, our primary key is lost and we are not having any record, that is any column that is uniquely identifying each and every record. Right? So now we require a value which will uniquely identify each and every record. That would be your GK value. That is your generated key value. Okay. So generated key value is nothing but it will give you a sequence of numbers for all the records.
Okay.
Okay. For example, give me a second. Yeah. So here it will create a GK values like 1, 2, 3, 4, 5, 6, 7 and 8. Okay. So another column will be added which will have GK values. Okay. Now GK values are used to identify your records uniquely in the normalized data. Okay. So this is your default ports. Okay, your purpose of your normalization is it normalizes your data, it eliminates redundancy and eliminates inconsistent dependency. Right. The properties. So coming to the properties of your normalizer transformation, you have reset, restart and tracing level. Okay. So reset is at the end of a session, it resets the value sequence for generated key value to the value it was before the session.
Okay.
Okay. So whatever the value it was before the session, it will start resetting to that value. Okay. And restart. Restart is nothing but it starts the generated key sequence at 1. Each and every time you run your session, it will again start from 1 only. Okay. That is reset and this is restart.
These are the values that
And
we will be giving. It's not default, right? Reset and restart.
yeah, it is a checkbox. You check
Yeah.
that box actually. Okay. And tracing level. So tracing level we have common, right? Normal, verbose data and verbose initialization. To implement your normalizer transformation, we take the help of an expression transformation.
Okay.
Okay. Like we use normalization and expression in we use both of them to get the normalized data into the target table.
Okay.
Okay. So using an expression transformation, what do we do? Okay. So inside your normalizer transformation, you have given number of occurrences. Right? So there what happens is your values get loaded there. Your name of the values or what the values is holding will not load. That you will be giving using your decode function inside your expression transformation.
Okay.
Okay, so decode is a function that you can use inside your expression transformation. Now let's see the syntax and what does a decode function do. Decode function works on a particular port. Okay, so the first thing you see here, value, that is called as a port name. Okay,
Mm-hmm.
on which port you want to decode, that name will be given there in the value column. Okay, and then you have first search, first result, second search, second result, and so on, and default.
Mm-hmm.
Okay, so first search, first result is nothing but whatever you give in the first search, it will search for it. Okay, then after it finds that particular value, it will decode, or it will put that value with this first result value. Okay, to explain this with an example here,
Mm-hmm.
see, we have a decode. Item is the name of a column or a
Mm-hmm.
port. Okay, and in the item port you have product 1, product 2, product 3.
Okay.
Okay, now after decoding, what happens is, in the item port, whenever it finds product 1, okay, it will give the value as 10.
Mm-hmm.
Whenever it finds product 2, it will give us 2. When it finds
Mm-hmm.
product 3, it will give us 3. If it doesn't find any of these 3, it will give us 0.
Okay.
Okay, so it's nothing but decoding. Okay,
Mm-hmm.
that is your decode function, and how you use your decode function.
So what
Okay,
if there is like lot of data that is being recorded? This is the way we will be using it, uh, like the product one. If say it is going up to product n, so if, till 1 to n we will be giving a value here.
yeah, yeah,
Okay.
but you don't get in such cases because decoding, you're normalizing your data. This is an example for product 1, product 2, and product 3.
Mm-hmm.
When you normalize your data, you will convert your columns to your rows there. Okay, so
Okay.
when you see this in the implementation, it will be easy for you to understand.
Mm-hmm.
Okay, if you have 10 products also, then you will be giving the 10 product names here only.
Mm-hmm.
Okay, let's implement it. So these are the transformations that we completed, right? Okay. So till union transformations, whatever you did were like standard transformations. Okay, they were not much complex. Okay, and your normalizer, your update strategy, your transaction control and lookup, these all comes under your advanced transformations. Okay,
Mm.
now let's see your normalization with an example. Okay. Yeah. Now I want to normalize this employee table in this way. I have my employee data, right? So I have employee number, employee name, job, MGR, that is manager, hire date, salary, commission, and department number, right? So I want a target table which will hold my employee name, employee number, okay, and job and the job value. Okay, so that will be my first record. In the second record, I'll have employee number, employee name, hire date, and value of hire date. Okay, and in the third record, I'll have employee number, employee name, salary, and the value of salary. Okay, so let me show you like this. Yeah. So here you can see you have employee number, employee name, job, hire date, manager, and salary. Right? So in my target table, what I need is, for example, you have the first employee, that is your Smith. Right? So my first record would be 7369 Smith. Okay. His job, that is, it should give me as job.
Right.
Okay. And the value is clerk. Fine. And in the next record, for the same employee, I want the hire date. Okay. So it will give me some hire date. In the third record, for the same employee, I require the salary. Okay.
Okay, so I see what it is, but I don't understand why do we need it like this? Why can't be in the same way the table is right now, and we can get the values from there, right?
You can get the values, but this kind of representation is different. This is normalizing your data, right? See here, your job, your hire date, and your salaries are columns.
Yeah.
Okay. But here, your job, your hire date, your salaries are records. Okay. Now, when I have the data in this way, it is easy for me to route the data based upon the hire rates, based upon the salaries, and based upon the jobs.
Okay.
Okay. So this is how we get it. Now for the next record, what we get is we get for the second employee. That would be Ellen. Right? And again, his job. Right? So in this way, what happens is for each and every record, you will have his job, his hire date, and his salary.
Great.
Okay. So we will be getting a target table in this way. That is, we will be normalizing in that way. Okay. Now let's see what we need to do to get the data in this way. Okay. So let me create a target table for this. So in the target table, what I'll do is I'll create an extra columns for GCID and GK values also. It is not necessary for each and every time when you create it, but for us to understand, because we need to know what values it is generating. Right? So for that, I'll create GCID and GK values. Okay. Now let us understand the structure here. We need employee number. We need employee name. Right? We don't want job as a column. So I'll remove it. We don't require MGR. We don't require hire date as a column. We don't require salary. We don't require commission. Neither we require department number.
Okay.
Right? I require employee number and employee name. Now the next column should be the type. Okay, the type or the property or anything.
Right.
Okay. right? So I'll create a column which will hold the type.
Mm-hmm.
That is it a job, is it a hire date, or is it a salary? That it will hold it here.
Okay.
Okay, so it's a varchar 2, fine.
Mm-hmm.
And here I'll remove this as a primary key because you will have
Yeah,
your
then
primary key will
right.
be yes, you have repeated values, right?
Mm-hmm.
Now I'll create another column, that is your type value.
Mm.
Okay, so here you get job and here you will get the value for
Job
your
type.
job,
Yeah. Mm-hmm.
right? And along with this I'll create two new columns, that is your GCID, okay, which is an integer or you can say number, and GK. Okay, so these are the values that we need to get. So I'll click on apply and click on OK. Now insert this into the target database. Okay, now let's create a mapping. Mapping, create m underscore name of the mapping, and drag your source. Fine. Now your normalizer. This is your normalizer transformation.
Mm.
Click on that and click on your mapping designer. Okay. Now we need not pull all the records or all the
Right.
columns onto the transformation, right? So what we'll do is first we'll go and define the ports inside the normalizer transformation. So edit your normalizer transformation. So inside your normalizer transformation you have ports, you have properties, and you have normalizer. Okay. In the normalizer tab we will be giving the number of occurrences. Okay. So here first thing would be our employee number.
Mm-hmm.
Right? So the employee number will only be for once. It doesn't have any number of occurrences. It has only
Mm-hmm.
one. And the second column would be your employee name. And this also occurs only for once, and the data type is string. Right? Now, the third would be the type value. Okay. Now, type value is nothing but the number of occurrences for your type value would be 3.
Mm-hmm.
Right? We have salary, we have hire date, and we have job values. So the number of occurrences is 3.
Okay.
So in your normalizer, what you do is you give your columns related to the values.
Mm.
Okay, and using an expression, what do we do is whatever the values it has generated, for that value we'll give a name. That is, it will decode it as job, it will decode it as hire date, and it will decode it as salary.
Okay.
Okay, so your type value will be generated here in the normalizer, and your type column will be generated in your expression transformation.
Mm.
Okay, now we have type value. Now let's move to the ports. What do we get? Let's see. Okay, so here what do we get is we get employee number in, employee name in, right? In is nothing but input port. Okay, and you get type values, 3 type values here, in 1,
Mm-hmm.
in 2, and in 3, right? So
Mm-hmm.
this defines that there is 3 occurrences for your type value.
Mm-hmm.
Okay, and these are the first 5 are your input ports, and the last 5 are your output ports. So in the output port, what you get is employee number, employee name, type value, GK type value, and GCD type value, which are your default ports.
Hmm.
Right? So we'll click on apply, click on OK. Now let's connect to the normalizer. So first our employee number will be connected to the employee number, employee name is connected to employee name, and I have type value 1, type value 2, and type value 3.
Mm-hmm.
Right? So I'll connect my job to one of my type value in, my hire date to the type value 2, and let me change it. It's a string, right? It's not a
Yeah.
decimal. Fine. Now I have connected to these values here. It means whatever the values that are there for your job, your hire date, and your salary, those values will be sent to your type values here.
Mm-hmm.
Okay, and they all will be held in your type value output port. Okay, now we will be connecting this to the expression transformation. Okay, now let's create an expression transformation here. Okay, along with this, I'll be creating a new port that would be the type port here.
Mm-hmm.
We'll click go to ports and here create the type port. Type is a string. Click on apply. Right, now this would be your output port. Now for your output port, select this as an output port. Right, now we can give an expression for the output port, that is type. So in the type, what I do is I'll be using the decode function.
Hmm.
Right, now
Right.
based on which port do we decode?
Mm-hmm. Mm.
The unique thing that we can find is the GCID port.
Mm.
Right, so we get values for each and every combination. Your employee and your job, your employee and your salary, your employee and your hire date.
Right.
So your GCID values are 1, 2, and 3.
Okay.
Right. So what do we say is whenever it finds 1, give the value as job. Whenever it finds 2, give the value as hire date. And whenever it finds 3, give the value as salary.
Salary. Okay.
Right. So we'll be writing a decode function here. So decode of GCID port. Okay.
Mm-hmm.
Comma. So when it finds 1, give the value as job. Okay, when it finds 2, give the value as hire date, and when it finds 3, give the value as salary.
Mm.
Right, now click on validate and click on OK. Apply. Now let's connect this to the target table. So let me connect this. This is clear, right? Why we are doing it?
Mm-hmm.
Now let's save it. Okay. Let's see. Does this make an error or not? Fine. Your workflow and your session task. Select your mapping. Give the mapping connections. And link the task. Save it. So let's say see the execution for the normalizer. Okay. So in this way we are trying to normalize the data. Fine. So here you can see the GCID values for the first 3 records.
Mm-hmm.
Your 1, 2, 3. And your GK values are generated, right? These are the sequence numbers that you get for your records. Okay.
Okay.
So you have any query in this, Priya?
Just that I still don't understand what scenario we'll be using this.
What scenario you will be using your normalizer?
Yeah.
Okay. See, it's easy for you to split the data when you have this kind of data here.
Okay.
Okay. First thing is, for example, I need my higher data results.
Mm-hmm.
Okay. And I don't require salary values or job values.
Okay.
Okay. Now from my normalizer, I can route it,
Mm-hmm.
giving the conditions on my type port,
Mm-hmm. Okay.
right? You cannot give conditions on your record columns.
Mm-hmm.
right? Multiple columns, you cannot give your conditions
Right.
when you are working with your router. But when they are in the form of records, you can give conditions.
Mm.
Got it?
Yeah.
So that would be one of your use with your normalizer.
Okay.
So let's see the next transformation that we have.
Mm-hmm.
Uh, Let me see this. Just give me we did not complete the tasks, right?
We
Any
did,
one task did we?
yeah, we did one task. I believe it is timer task.
Okay, so it's
Believe it.
timer, right?
Yeah.
Okay, control and decision. Fine. Okay, but let me go to the presentations. We did not complete SCD also, right?
No.
Okay. Let me start with SCD today.
Yeah.
We'll have discussion on SCD
Mm-hmm.
and then we'll discuss about a new transformation.
Sure.
Yeah. So coming to your slowly changing dimensions, these are some important topics, okay, inside your data warehousing concepts again. Okay. So this is a generalized topic that you can relate to your data warehouse, your database also. Okay. So let's see what is slowly changing dimensions and what are the types of slowly changing dimensions. Okay.
Mm-hmm.
So this entire SCD is related to your dimension tables. Okay. So
Mm-hmm.
if you remember, a dimension table is nothing but which holds the attributes that are related to that particular dimension,
Okay.
right? So let's see what is slowly changing dimensions, types of slowly changing dimensions, and how do you implement them. Okay. So slowly changing dimensions are nothing but dimensions that change over time. Okay. There is no table that will be stable throughout the years,
Mm-hmm.
right? There might be a slight change in the table data,
Yeah.
right? So the dimensions that change over time are called as slowly changing dimensions.
Mm-hmm.
Okay. For instance, a product price changes over time,
Right.
right? So there is no need like necessary that your product price will remain the same for 5 years, 10 years or 15 years.
Mm-hmm.
There might be a longer time or a short time, but your product price will change.
Right.
And there might be some people who change their names for some reason, they change their location, they change their addresses and everything.
Right.
Right? So what happens when you want to give a change or update this change in your data warehouse data? Okay, so these all comes under your slowly changing dimensions. So we have types of slowly changing dimensions. Before that, we'll understand the principles of slowly changing dimensions. Okay, most dimensions are generally constant over time, and many dimensions, though not constant over time, change slowly.
Mm-hmm.
Right? Whatever might be the change and whatever might be the change that you make, the product key of the source record should not change. Okay, the product key is nothing but your primary key or your business key. Okay, the key should not be affected whatever the change that you make to your table.
Hmm.
And the description and the other attributes slowly change over time. Okay, so the description might change, the other attributes might change over time, but your key will never change.
Hmm.
And in the OLTP systems, what happens is the new values override the old ones. This is because at your OLTP system level, you need not maintain the history.
Hmm.
Right? So what happens is whatever the new values that you get, they override the
Hmm.
new values,
Mhm.
old values. Okay, and overriding of dimension table attributes is not always the appropriate option in a data warehouse.
Mhm.
So in data warehouse, we do not override the values because we need to maintain the history. We append the data, we do not override the values.
Right.
And what are the types now? We have type 1, type 2 and type 3.
Mhm.
Right? So no history, partial history and full history. Okay? So we say in this way, but your type 2 will have full history, type 3 will have partial histories.
Why? Why?
Okay, they give you, like whenever you refer, you get the data in this way, but
Mhm.
your type 2 will have full history and your type 3 will have partial history. Okay, it's a crisscross here.
Okay.
Okay. So let's see type 1, type 2 and type 3 and let's understand what are the differences between all the three types. Okay. So type 1 is nothing but it is related to the correction of errors that you get in your data. Okay. So usually relate to correction of errors in the source system. Okay. The best example is my customer name is misspelled in the source data.
Mhm.
Okay. I need to change it. The
Mhm.
new value should override the old one here, right? Because there is no need or there is no necessity that we need to maintain the misspelled data.
Right.
We don't need it at all. There is no use of it. So we will discard that value and that value will be overridden by your new value. Right?
Mhm.
Whenever you do such kind of updation, then that is called as type 1 SED. Okay. Now general principles for your type 1 SED is usually changes relate to the correction of errors in the source system. Okay, wherever you get some errors and you need to make some correction for the data, then you go for SED type 1.
Mhm.
Sometimes the change in the source system has no significance. That is true. There is no significance of misspelled name, right?
Mhm.
And the old value in the source system needs to be discarded, right?
Okay.
The change in the source system need not be preserved in the data warehouse also. These kind of errors need not be preserved in the data warehouse. Okay. Now your type 1, what happens is the errors will not be preserved in the data warehouse also. In the data warehouse also the values will be overridden with the new values.
Mhm.
Right? Because there is no significance of the error that you are getting. Okay. So this is your type 1. So how do you apply your type 1 SED? First thing is overwrite the attribute value in the dimension table row with the new value. Right?
Okay.
Wherever you find the error, go and overwrite that value with the new value.
Mhm.
And the old value should not be preserved. Try to delete that old value.
Mhm.
And no other changes are made in the dimension table row. Apart from this change, there is no other change that is made in the table.
Mhm.
And the key of this dimension table or any other key values are not affected.
Mhm.
Right? And it is the easiest to implement because we can delete the data and we can override the values.
Mhm.
Right? So this is about your type 1 SED.
Okay.
Now coming to your type 2 SED. Your type 2 SED is important among all the types because it maintains the full history.
Right.
Okay. And let's see how does it maintain the full history. Yeah. Type 2 is used to extract the history of changes and they usually relate to the true changes in the source system. Okay, they do not relate to any errors or warnings that you get. They are related to the true changes. There is really a change in the data, then you go for your type 2. And there is a need to preserve history in the data warehouse. Here you will not overwrite the value, you will append the data. This type of change partition the history in the data warehouse. Okay, that we will see after seeing the example. Every change for the same attributes must be preserved. Okay, now let's understand with this example. So we have a food table, we have keys, that is we have names of the food items, we have type key and the price, right? So here you can see type key is nothing but depend upon the food item, the type key is defined here.
Yeah.
1 and 2. Now this is fine. This is for my first year. In the second year, what happened is I'm changing my values of my French fries from 2 to 3.
Okay.
Now how do I store this data in the table? First thing what we do is when we change to an SED, we start giving 3 columns, that is your date from, date to and latest flag. Date from and date to help you to understand when your particular record is active.
Okay.
What is the duration? Okay. For example, my French fries here is 2, right? From here I'll be changing it to 3.
Right.
Right? So when I change it to 3, there might be some duration between which your French fries price was 2 is active. That date you will specify here, from date from to date to. Okay. So this is called as effective date.
Now
So how do you
once we change the French fry type key to 3, the date from and date to will show the date from which the duration in which the French fries were given the value 3, right?
it will show you 3 and it will also show you 2.
Okay. How does that happen?
Yeah, I'll let you know. Now this is, you understood what is effective date, right? So date from and date to, it is nothing but the duration for which your record is active.
Okay.
Okay. Now everything is fine as you said. Now we have a scenario wherein I need to update my French fries price. So depending upon the dates here, let's understand 1st January 11, okay, to 31st December 99. Okay, so it might be 2011 or 2019, whatever it might be. Okay, so 1st Jan 11. Now what happened is I am in the month of November. Okay, I am in the month of November 99. And I want to change my French fries price to 3.
Okay.
Okay, now what I do is, first thing that I do is I update my date from and date to for this record. That is, my 2 price was active from Jan 1st 11 to November. For example, 30th November 99.
Okay.
Okay, I'll update here first. Well, first thing that I'll update is I'll update the end date of my French fries price. That
Right.
is 30th November 99.
Okay.
Okay. Now, after this is happening, I'll add a new record to my table. The key will be 5. The name will be French fries. The type key will be 2. The price will be 3. Okay. And the date from will be 1st December.
Right.
99 to some future date.
Okay.
Okay. It might be 31st December 99.
Okay.
Now we are partitioning your history, right, with the help of dates.
Right.
Right. So this is how you try to store the changes for your data with the help of your effective dates. Okay. And coming to your latest flag. Now what is the latest flag? When you start appending your data, you need to know which record is active now. Right? So as soon as you see a table, you need to get the records that are active, or you need to pull the data from your table for which your records are active. then what you can do is you can take the help of latest flag. Your latest flag will help you to understand which record is active. Y is nothing but your record is active. Whenever it has N, it means it is not
Not
active.
active.
Okay. So here French fries, now it is active.
Okay.
When I add a new record with French fries price is 3, this particular third record will become N and your new record will become Y.
Right. Yeah.
Right. So
Yeah.
your flags will help you to know which records are active and which are not active.
Active.
Okay. So this is your type 2 SED. And yeah. So this is what, right? We have seen the slide. Yeah. This type of change partitions the history in the data warehouse. Now, how do you partition the history is with the help of your effective dates.
Date.
And coming to your type 3 SED. Your type 3 SED is hard to implement, time consuming and hard to maintain. Okay. So what happens in your type 3 SED is one current record, okay, and one previous old record will be stored. Okay. For example, I have key and attribute. These values are my managers. Okay. For example, A, B, C are the managers in my organization. Okay. Now, my A is replaced by a new manager D. Okay. The current record is D. It will get stored, and the old previous record is A that gets stored here.
Okay.
Okay. And my D is replaced by E. Okay. When this happens is, what happens? Your E will be your current record and one previous record that would be your D will be stored.
Okay.
Okay. The previous record to your D is A. Right. So in this way you will be adding your columns here. In your SED type 2 you add records. In your SED type 3 you add columns. Okay. To understand this is very easy, but to implement it is a very complex task. Right? Because you need to add columns, you need to change the data whenever required, you need to know which is your previous record and which is your current record. Right? So these all things need to be combined and it should be implemented. So that is why this SED type 3 is complex and hard to implement. What are the general principles of SED type 3? These usually relate to soft or tentative changes in the source system. Right? And there is a need to keep track of history with old and new values of the changes attributes. So your SED type 3 concentrates on the new and your old values. And they are used to compare the performances across the transition. They provide the ability to track forward and backward. Okay, these 2 points are nothing but you can easily compare from which manager you have changed to other manager.
Yeah.
And you can move forward and backward. That is, I can know from my first manager and I can know my current manager. Right? Moving forward and backward is moving backward to your initial data. Okay. So with the help of this type 3 SEDs, you can perform these kind of things. You can move forward, backward, get your data. Okay. And you can compare performance across the transition. Okay. So this is about your type 3 SED. So you have any queries in this SEDs, Priya?
No, not right now.
Okay. So you can just go through this presentation of your SED. Okay. So what all questions you get is on your concepts only with your SEDs.
Okay.
What is type 1? What is type 2? What is type 3? Okay. What kind of columns you use in your type 2? Okay. So these kind of things you get in your SEDs. Fine. Yeah. So we'll meet for the next session and we'll try to complete the next transformation. Okay.
Okay. And tomorrow morning, right?
Tomorrow morning?
Tomorrow night, yeah. My morning, your night, yeah.
Okay.
8:30 p.m., right?
So, yeah.
Okay. Okay. Okay, Lakshmi. Thank you.
Yeah, let me think actually because tomorrow is 31st for
Yeah,
us, right?
that's why I asked you, yeah.
Yeah. So I think we might have some celebrations. So let me continue from first. First, you have your celebrations.
Uh, even I have to think here. 31st tomorrow morning. Yeah, I will be first. 31st night would be your morning. I can come on first morning. Yeah, 10 o'clock would be fine. Yeah, I'll get up. Yeah,
No, 10 o'clock. Like first morning is mine.
your first night.
Okay. So you'll be available on that day.
Yeah, first morning, 10 o'clock is fine with me. Yeah.
Okay.
If you
Okay.
want, I
So
can come tonight. Tonight too.
tonight is my 31st night.
No, 31st morning.
Tomorrow morning.
Yeah, your morning. Yeah.
Yeah. Like no, tomorrow morning. Like almost like already have a session in the morning.
Okay. Okay. So first
Yeah.
then, first 8:30.
Yeah.
Okay.
Yeah. First 8:30 I'll be
8:30
available.
p.m. Okay.
Yeah. Okay.
Okay.
Yeah.
Bye.